All right, welcome to this video. This is a video that reviews our standards around types of numbers and Pythagorean theorem. Let's go ahead and talk about the difference between rational and irrational numbers. So rational numbers are numbers that can be written as a fraction, repeating decimal, or terminating decimal, or whole number and natural number. So as you kind of see here in this graphic, the real numbers have two groups inside of them that sit inside of them, the rational and the irrational. No number is both rational and irrational. It must be one or the other. Then within the rational numbers, there are integers, whole numbers, and natural numbers. Those are the integers is positive and negative whole numbers. Natural numbers is the counting numbers. Then irrational numbers are these like square root of 3, square root of 5, pi. They can be turned into decimals, but the decimals never repeat or terminate. All right, so let's go ahead and let's remember that a rational number is a integer, a fraction, a terminating decimal, and a repeating decimal. And the reason why repeating and terminating decimals are rational numbers is those can both be turned into fractions. And then irrational numbers would be examples like pi, square root of 7, cube root of 12, all sorts of different things like that. So when turned into a decimal, they are non-repeating and non-terminating decimals. All right, let's go ahead and look at some things here. It says identify the rational numbers. Okay, there's going to be a couple of things I pull up from my calculator here. There's a couple of them we can just identify. This is a fraction, so this is rational. Okay, rational. Square root of 57. Now, square roots. We got two square roots sitting next to each other. The square root of a perfect square gives us a whole number, which is rational. So if I want to go ahead and I want to look at and think about what is a rational number here. If I type in the square root of 57 and I type in the square root of 100, okay, the square root of 57 gives me a decimal. Though that decimal ends on this calculator view, it is not rational. It goes on forever. The square root of 10, okay, that is rational. Or the square root of 100, that is rational. So here, this is irrational. And this one here would be rational. All right, 6.7643. That is a terminating decimal. Do you see how that ends? Terminating decimals are rational. Negative 5/3, that's a fraction, that's rational. Negative 16, that's an integer, that's rational. And then pi minus 4, that is irrational. If pi is ever present, we are going to have an irrational number. All right, now let's talk about the square root of 87. Got a little something going on here. Okay, there we go. All right, square root of 87. Between which two integers does it lie? Oh, that's an interesting question. Well, we could go to a calculator, or we could think about perfect squares, okay? If I want to know between which two integers is the square root of 87, okay, I need to know which two perfect squares does 87 sit between. So if I list my perfect squares in order, 1, 4, that's 2 squared. 3 squared is 9, 16, 25, 36, 49 is 7 squared, 8 squared is 64, 9 squared is 81, 10 squared is 100. All right, there we go. This sits between the square root of 81 and the square root of 100. Okay, because 87 is between 81 and 100. The square root of 81 is 9. The square root of 10, the square root of 100 is 10. So the answer is between 9, and 10. All right, solving equations involving square roots and cubes. Sorry, squares and cubes. Okay, just like a normal solving equations problem, we have to isolate the variable. Okay, so we're going to add 11 to both sides. 5x squared is left, equals 267. Ooh, this is going to be ugly. We're going to divide by 5. That's okay. We're going to get x squared equals 267 divided by 5. 267 divided by 5 is 53.4. Now, when I see this x squared equals, I need to square root both sides. A square root undoes a square. So we're going to end up with x equals the square root of 53.4. Okay, we get 7.31. Now, that's not the whole story. There's another solution. There's positive 3.71 and negative 3.71. There are two solutions to this equation because both numbers would work because we're in the middle of a squared equation. All right, let's go ahead and do this cube root problem. We're going to subtract 5. We're trying to isolate the x cubed. So we're going to subtract 5. We get negative 2x cubed equals 16. We are going to divide by negative 2. We get x cubed equals negative 8. Now, here's the thing. We're not going to square root because we have a cube. We are going to cube root both sides. So when we cube root both sides, we get x equals, now I need to go to my calculator and take the cube root of negative 8. So the cube root, if you look to the left next to pi, right in the kind of the middle here, there's that n over the square root sign or the radical. If you hit that, the cursor will be kind of bouncing there. If you put a 3 above the square root and then click into the square root and hit negative 8, you get negative 2. Why does this work? Because negative 2 cubed is negative 8 because it's negative 2 times negative 2 times negative 2. We end up with a negative number. With cubes, we only get one solution. The solution is either positive or negative, not both. So there's the difference between those two. All right, next problem is Pythagorean. Okay, so let's go ahead and look at this. We know that a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So looking at this triangle, we would have a, b, and c. C is across from the right angle. A and b can be flipped, doesn't matter. Let's go ahead and write out those numbers into the equation. 25 squared plus 21 squared equals c squared, or you could just put the x in there. That works too. Now, I don't know what this is. I'm going to have to go to my calculator, and I'm going to calculate all of that at once. So let's open up our calculator, and I'm going to clear this off because I got a lot going on. 25 squared plus 21 squared is 1,066 equals x squared. Now, just like above, we square root both sides. So I go to my calculator, and I'm going to get x equals the square root of 1,066. So here we go, the square root of 1,066. The other way you can do this is you can use the below the 3 there next to the plus sign. That ANS button will bring in the previous answer. That's helpful. 32.6. 32.6. Now, is negative 32.6 a solution? No, it's a solution to this equation right here up top, but in the context of a triangle, negative 32.6 makes no sense. We cannot have a negative distance. That doesn't make any sense. All right, last question. Now, here, we're not looking for C. We know what C is. C is 38. I'm going to make AX and B11. Again, those are interchangeable. We're going to plug them into the equation. A squared plus B squared equals C squared. So we're going to have x squared plus 11 squared equals 38 squared. Now, we have to go to our calculator and we have to square those two numbers. So let's go to our calculator. We're going to square 11 squared and 38 squared. So we have 121 and 1,444. So 121, 1,444. Whoop. We are now going to subtract 121 from both sides. We are isolating our x squared. We will end up with 1, 3, 2, 3. And then, just like in the previous problem, we square root. So I want to get x equals. Go back to your calculator. You can take 1,444 minus 121 if you didn't believe me. Okay, then you can do square root of the answer, and we get 36.4. All right, that is the Pythagorean theorem, and that has been our quick video reviewing those two standards.